Hello class, this is Ms. Chikoy. So I'm going to very quickly go over these. I was only able to get to the paper today, which is why this is going out late. So if you think that any of them are wrong, feel free to correct me in the comments so I can go back and change things. So let's go ahead and start. So one was the vertical component of a 33 meter vector that is at a 76-degree angle with the x-axis. So you can always draw that. We have a 33 vector is at a 76-degree angle, and we want to know from the x-axis, and we want to know the vertical or the y component. Hopefully you can see that that is the opposite side, so therefore we're going to be using sine 76 times our hypotenuse will give us y, which will give you 32.0. So we should be able to safely say that is D. Alright, 2, a possible angle that a vector with a magnitude of 17 can make with the x-axis so that its horizontal component is 12. So again, this is just another triangle problem where they said the vector is some 17 in magnitude. Make some sort of angle theta where we know the horizontal component is 12. So we have the hypotenuse. That would be cosine. So we know cosine of some theta is equal to the adjacent over the hypotenuse, which means we're doing cosine inverse of that, which should give you 45 degrees. Alright, 3. A ball is thrown horizontally out of a building at 8 meters per second. The building is a height of 250 meters. So remember, you have two problems. You have an x and a y direction problem. X, the initial velocity is 8 meters per second. Y, the initial velocity is 0. Here, acceleration is 0. Here, acceleration is -10. And you know that its initial position is 250. That looks like an 8. And its final is 0 because we care about when it lands. And this we want to eventually find delta x. So we first need to find t via the y side. And we know that initial velocity is 0, so using this equation, we can cross out our v. And we're solving for t squared, so we get x minus x naught over a, all of this times t, or times 2, is equal to t squared. Therefore we have to square root this. We can plug in some numbers, and I will erase this when I go on to the next problem, but 2, essentially negative 250 over -10, get the square root of it, should give you about t equals 22.4 seconds. Then we can go ahead and plug this in, and on range, the velocity is the only thing that matters. Since there's no acceleration, we can essentially, all we want to know is the change. So we're going to have 8 times 2.24, which gives you 178.9, which we can round to 180, or e. For what vector represents the displacement of a person who walks 15 kilometers and 45 degrees south of east? So if it's never eat soggy waffles, south of east is this direction, and that's a 45-degree angle, 15 kilometers, and then after this they walk due 30. Due west. So opposite direction. I go due west 30 kilometers. So like any vector, we should probably break our one at an angle up. Luckily you know that since it's a 45-degree angle, sine of 45 and cosine of 45 are going to be exactly the same, so it doesn't really matter, but you know they will be the same. And that is 10.6, so we know that if we were to break this up, that they went 10.6 east and 10.6 south, and then 30 west. So hopefully you could start seeing that, oh, these two right here, you should subtract them. So they cancel each other out a bit if this was our origin. And if we do that, we know that ultimately we went 19.4 and then 10.6 south. So I just moved that, and this is the angle we want to find. So we can use tangent, or inverse tangent as it were, to give us the opposite over the adjacent. Which would give us 28.7, or roughly 29 south of west. Alright, 5 sounds like you should do something. At its maximum height, the vertical component of velocity for an object projected at 4.9 meters per second at a 6-degree angle is. Here's the thing, you don't have to do anything because we asked about the vertical component of the velocity. Remember, if anything goes up, right here, its velocity in the y direction has to be 0 because it's the difference between where it went up positive and where it goes down negative, which means the answer must be C. So again, this is vectors and angles. So if it's heading towards its destination at 175 kilometers per hour, but there is a westward wind blowing at 25 kilometers per hour, that means it's going to be off. So what angle should it account for and therefore reorient for? So it's going to want to go this way so that when it gets pushed, it ends up in the spot it wants to go. Alright, so you have to figure out that angle. And again, this is a tangent problem since it's 175 kilometers north, 25 west. You want to find the angle. So it's going to be tangent inverse of the opposite over the adjacent. So it'd be 25 over 175. And if you put that in, you're going to get about 8 degrees, or A. Number 7 is related. So if it has gone that amount of distance, how far would be off course if it didn't compensate? So when we're saying north, so we want to use the north vector to figure out how long it would take to go that far, and hopefully you can look and be like, oh, that'll take 10 hours. If you can hear the whining, I apologize, that's my dog in the background. 10 hours, and then we know it's going to go 25 kilometers per hour westward. So we know that it'd be off track by 250 kilometers. And all this is asking you to do the same idea, but now just find the resultant vector. So if these are our two components, what would the magnitude of the velocity be for the resultant velocity vector? So you could do any number of things. You could do tangent because you have the angle, or you could do Pythagorean theorem. Sorry, it took me longer than it should have. Either one, it doesn't really matter. I'm just going to do this one because we haven't done it yet on any of the things we've done. on this page. This gets us 176.78, which should round us to E. Now, what velocity should a ball be thrown at a 45-degree angle so that it hits a target that is 20 meters away and placed at the same height? Easiest way to do it is your range formula. Hopefully you remember deriving it. This is where the original velocity sine 2 of the angle over g would get you the delta x in the x direction. Except in this case you're solving it for your v naught. There's a lot of ways that you could also go back and derive this. I'm not going to show them because time reasons, but you could just easily go back and manipulate this to look like this and then plug in your values. And this gets you 14.14, so I would go with D. Alright, multiple choice questions. Which of the following values are vectors? Instantaneous velocity, distance traveled, average acceleration. Hopefully you remember that velocity is a vector. It has directions. Acceleration has a vector. However, distance is not a vector. That would give us 1 and 3 are correct. D. 2. For an object that traveled 20 kilometers north and 15 kilometers south, what is the ratio of the distance traveled to the displacement? So you want to look at both the displacement and the distance. So what that means is the distance it traveled is everything that it did. So the distance would be 35 kilometers. The displacement is that it went 20 north and then 15 south, so really you're only 5 from where you started, and then you want to set up a ratio between them. And I want it to the distance traveled to the displacement. So it would be 35 to 5, and if we simplify this, it would be 7 to 1. So the ratio would be 7, and obviously this looks really similar, so you just have to be really careful which one is it talking. It's the ratio of the distance to the displacement, not the displacement to the distance. Alright, for an object that travels 60 meters east and then 60 meters west in 15 minutes, what is the ratio of the average velocity to the average speed? So you really need to think, if it went 60 meters west, 60 meters east, that means the velocity is going to be 0, because it hasn't gone anywhere. Not really. And the average speed, however, well, it doesn't really matter, because this is 0. Which means your answer cannot be a number, so it's either 0 or undefined. So since it's a ratio of the average velocity to the average speed, whatever the speed was, you don't have to calculate. You can, but you don't have to. Our answer would be A, 0. Alright, a bullet fired horizontally from a height 3 meters, the velocity of 120 meters per second, hit the ground after how many seconds? So hopefully you know that this 120 doesn't matter because it was fired horizontally, so it has nothing to do with when it hits the ground, because all we're talking about is in the y direction, which is 0, because it was fired horizontally. We know that our displacement is 3 meters. Sorry if you can't hear my dog whining. I definitely can. It's a little distracting. That acceleration is always negative 10 meters per second squared. So we can solve for the time. And then go ahead, plug in. B2, this would be negative 3. That way when you do this negative 10, it all works out. Square root of 0.6. Which is 0.77, or roughly 0.778. If you had used 9.8 here, it would have worked out slightly better. 4. What is the final velocity of an object constantly accelerating from rest at 14.5 meters per second over 35 meters? So we want to know the final velocity. So hopefully you remember this equation. If you don't, it is on your equation sheet. We know it's starting from rest. This one doesn't matter. So we just need the square root of 2a, which is 14.5 over 35 meters. And this gets us about 32, or E. What is the average velocity of an object that travels for 20 seconds with a starting velocity of 7 meters per second with a constant acceleration of 25 meters per second squared? So you need to find the average velocity. The only way you can find the average velocity is you first need displacement. So you got to figure out how far it went. And then divide that by the total time it went. So probably the easiest way to do that, you know that x equals x naught plus v naught t plus 1/2 a t squared. Go ahead, plug in. You can move this over to get your delta x. 7 times 20 plus 1/2 times 25. I know you can't see that. 20 squared gets us 5,140. And if you see any mistakes, please let me know. I'm going very fast and not checking my work as much as I normally would. And then you would take this and divide it by your 20 seconds, will get you 257. My dog is getting increasingly upset. I'm not paying attention to her. How long does it take a car accelerating constantly at 4 meters per second squared from rest to travel 200 meters? So this is a how long does it take problem or time. We want to essentially know how long does it take to get that far. So first equation is what we're going to use, what we're going to solve for time. Which hopefully you've gotten pretty used to this equation. Plug in, and this gets you 10 seconds, or C. What is the minimum positive initial velocity necessary for an object to be launched from ground level so that it reaches a height of 80 meters? So we know that the final velocity is 0. We know the acceleration has to, so we need to find initial velocity. So easiest one, you could use others, but this would be the best. You're essentially solving for the initial velocity. And you want to know, and we know that final velocity is 0 because it's at the top. And we can go ahead and plug in. Gravity's negative 10. We want it to go up 80 meters. Solve it. And that equals 40. So D. Assuming negligible air resistance, how long will it take a sphere to fall through 36 meters if thrown downward at 12 meters per second? So we can assume that the final, well, we're going to use this one. We want to solve for time. However, our initial velocity is not 0, so that's something you want to take into account. So you can't, unfortunately, let it cancel out, although that would be nice. If you just draw a quick sketch, so if we want, we can call this 0 and this negative 36, or we could call this 36, and the final position 0. Either way is going to end up looking like this when we manipulate it. And if you're wondering where I got the 5, that's half of negative 10. And then you'll notice we're going to have to factor, or do the quadratic formula. Since it is non-factorable, you have to do the quadratic formula. If you did, you would get that t equals 1.75, or it equals negative 4.2. Hopefully you understand that negative time is not possible, therefore it's the 175 seconds, or 1.75 seconds. What is the magnitude of velocity of a blah 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 after free falling from rest after 3 minutes. Doesn't matter what it is, all we want to know is the velocity after it fell for 3 minutes. So remember, this is in minutes, we need to turn this into seconds. Hopefully you know there's 60 seconds in a minute, therefore it's 180 seconds, so it fell for quite some time. And I just want to know the final velocity. So we don't really need much besides this equation, because we know it fell from rest, so that's 0. And we know that's 100 meters per second squared, so we get 100. Basically, we get a large number, although if you looked at the answers, you might be able to think, why do they happen to have two that are on the same scale? But it would be E. Was the magnitude of acceleration 1.5 seconds, sphere thrown upwards from a height of 15 meters at 20 meters per second squared? So basically, all of these numbers are meant to confuse you, because they said after it was thrown, which means since it was thrown on Earth, assuming, that the only acceleration it could have is 9.8 meters per second squared. And just some things to remember when you're talking about these, just understand the difference between the average velocity is not the same as the instantaneous velocity. Average velocity is the change in x over change in time. Instantaneous velocity is the change in x over the change in time as t goes to 0. If you don't understand calculus, don't worry, but this is just at that exact moment. This is over a large period of time. Same for the average acceleration versus the instantaneous acceleration. Also, key ideas is always think about what happens to velocity at the very top. In the y direction, the velocity in the x direction is the same as it was in the beginning because there's no acceleration. What's acceleration on Earth? These kind of ideas. I will be there early before school if you'd like help. And good luck tomorrow on the test.